Assalamu alaikum warahmatullah. Now we will discuss tensors, dealing with not the first derivative, the Jacobian or the gradient. Now we want to take the second derivative, the third derivative, and general higher order derivatives. Okay, so we have a higher dimensional tensor with higher order derivatives. So things are getting complicated, but it's not that complicated if we concentrate a little bit. Okay, now if we have this simple function that takes a vector into a scalar, that maps a vector into a scalar, like this thing, right? Remember that the second derivative with respect to x has this form, and the nth derivative has this form, right? Okay. Now let's take the partial derivative with respect to y and then x, right? So this is the form. So here we take the partial derivative with respect to x, then y. The general case, the arrangement or the turn of taking the derivative matters, but it's not always. So if fx is twice differentiable, which is the case that we're dealing with here, the order of the derivative does not matter. So if we take partial y, partial x, it will be the same as partial x, partial y. Okay, this second order derivative in general it's called the Hessian. So the first order derivative is called Jacobian or gradient. The second order derivative is called the Hessian, right? So it takes actually it is a matrix that collects the second order derivatives. It has another form, which is nabla squared with respect to x and y. So what is the Hessian matrix? The Hessian matrix is a 2 by 2 matrix, right? So the first element is the second order derivative with respect to x. The second one is partial x, partial y, and the third one is the opposite with respect to order. It's partial y, partial x, and the last one is partial y squared. So you take the derivative with respect to y twice. Note that this matrix is symmetric. Why? Because of this condition, right? Okay. So in general, for an n dimensional, let's say n dimensional multi-valued function, right? So this is a multi-valued function that takes a vector and maps it to a scalar. The Hessian is a square symmetric matrix. It's n by n, right? If the function is vector valued, you will get a Hessian tensor. Hessian tensor. It's m, which is this, by n by n. N is the dimension of the input vector, right? Okay. So let's take a simple case, right? Or let's take a general case here. So let's take we have this function, right? So it maps R2 to R1 or a scalar. So x has two components, let's say x and y. The third order derivative, it does not have a specific name like a Hessian or Jacobian, right? So we just call it the third order derivative. It is denoted by d cube with respect to x and y of f. You take the derivative of the Hessian with respect to x the first time, so this is a tensor, and this is the second tensor, right? So it's 2 times 2 times 2. Why? So it's 2 by 2 is the Hessian, so this is the Hessian. So this is the Hessian, and this is because we have two derivatives, x and y. Okay. So if we want to index this third order derivative tensor, so we say like this: the first two indices, they index the Hessian matrix, and the last index, it references the page, as we said earlier. So this is page 1, which is the Hessian derivative with respect to x, and page 2 is the Hessian derivative with respect to y. Okay. As for the elements of the Hessian derivative, as you can see here, so you have a third order derivative with respect to x, and then you should be careful, right? So here then you take the derivative with respect to y, then x twice. Here you take the derivative with respect to y, then x, then y. Here you take the derivative with respect to y twice and then x. Okay, so I think this should be clear with an example. Okay, so this is the function that we want to derive. Okay, so this is a function, right, that takes an R2 and maps it to a R. So this is what this is, a multi variable function, right? And we want to find a third order derivative tensor. Okay, so what we need to do, we need to find the Jacobian and the Hessian, then third order function or tensor. So in order to find this, we need to find this and this. Okay, so let's find the Jacobian or the gradient or the first order derivative. Okay, so you take the derivative with respect to x, then respect to y, and put them as a what? A row vector, right? So we put them like this. So it's 2x plus 2y. Remember, it's a row vector. Then the derivative with respect to y is 2x plus 3y squared, right? So you take the derivative with respect to x, you get here 2x, then 2y, and then this goes away, and the same thing when you take the derivative with respect to y. Okay, now, so this is the Jacobian. So we found the Jacobian. This is the Jacobian. So the Jacobian, right? Great. Now we want to find the Hessian. Remember, the Hessian is a 2 by 2 matrix now. It's a 2 by 2 matrix, right? And it is a symmetric matrix. So what we need to do, we need to take the derivative of fxy with respect to x twice, or we take the derivative of this one with respect to x, right? So if you take the derivative of this with respect to x, you get 2, right? Then we want to take the derivative of let's say this one with respect to x. So this, find this thing, right? Take the derivative of this with respect to x, right? So just look at this function. Okay, derive it with respect to x, you get the same thing, you get 2, right? Now let's say that we want to find the derivative with respect to y twice. So you take this and you derive with respect to y, so you get 6y. Okay, now we want to find the derivative of this first with respect to x and then y. We have this one, right? So you take this, you take the derivative of this with respect to y, you get 2 as well. Remember that this is a symmetric matrix, so this element and this element, they must be equal, since this function is differentiable, right? So okay, let's write down the Hessian here. What is the Hessian? This is the first element, it's 2. The second element now is this one, it's 2. The third element is this one, it's 2 as well, and this is, we get 6y, right? Now remember, we need to find the third order derivative or tensor. So what is the third order tensor? As we said, there is d cubed x and y of f. This is what the partial derivative of Hessian with respect to x, then the partial derivative of the Hessian as well. Sorry, what is this? Okay, so it's yeah, okay. with respect to y, as we said earlier, right? So it's either you find all of the components separately, or you can look at this. Okay, this is the Hessian, and I want to take the derivative of this Hessian with respect to x. See, we don't have any x's here, so the derivative is 0. So this is an all 0 matrix, right? So it's 0, 0, 0, 0. As for this, you take the derivative of this with respect to y. So you get this one. So the derivative of the first element is 0 with respect to y. The second element is 0. This is 0, and here it is. So this is 0, and let's write it in a nice way. Right. So 0, and this is 6. Right. So this is the tensor that we have here. So this is the Jacobian, so this is the Hessian, and this is the tensor, third order derivative tensor, right? Okay.